it's Kurt. So, I was tweeting at some very important people a while back, warning them about my machine and how cryptography was going to be ruined. But that was just my anxious self. I just computed the results, and it looks like we can't be omniscient with a machine. I really wish that we could, but to reuse time, you need a god awful lot of space. And so basically, this is how this is how the terms, the number of unique terms, and by terms I mean if you have like T1 or T2 or T3 in brackets, or like as a clause. So terms, when I speak terms, it's in between the ors, and when I say clauses, they're in between the ands. Okay, that's Kurtlish. I don't know if it's real. But dependent on the number of terms that you have, or term length, 2 to the term length, because everything's in binary terms. This is how your terms change. So I put the term number of terms, and it's, remember, the term length is the square root of this, but not the square root. Log 2. Goddamn. You can't even do math. You're fucking. I put it on my social media because I need, like my other social media, because I need people to know. But it's definitely log 2. I think. You know what I'm talking about. If you know what I'm talking about. If you don't know what I'm talking about, you don't know what I'm talking about. But this is the term, like, these are the number of unique terms. And, well, yeah. And these are the number of unique clauses. And you can see, like, my clauses are, it's like you get to 2.5 milli when you get to 256 unique terms, which is only a term length of, I don't know, it's not very much. 256 log 2. 2 to the 2 to the 1, 2 to the 2 to the 8 is 256. So 256, you already have 2.5 million clauses. But then when you when you start to compute your your unique strings for a given term length, that's when you have to sum over a permutation, and that's probably like best case scenario, depending on your resolver algorithm that's taking an infinite number of strings and bringing them down to a finite number of strings, which is the number of states that you're going to need for any term length bounded by this, is what I'm trying to say. Unique terms. For 4 unique terms, otherwise a term length of 2, which is basically your minimum if you have a flip digit. I didn't finish computing it, but it's a bunch of numbers summed over each other, and the highest number is 2.4329 times 10 to the 18th. And that's not even, then you have to multiply that. That's just like the number of things you'll have to store. You have to multiply that by the bytes that you actually have to store, which is for the number of unique terms. So you'll just multiply by the number of unique terms, and that's worst case if every single unique term is used in your string, because you just have to have the answer and then like the length of the string. So the space that you're using is fucking crazy. But the thing is that in Turing machines, I'm putting all this in the transition table, so it's not really using space in the Turing machine sense because it's not writing it down. The space that it's using to write down, which is really only like memory for a computer, is very minimal. It's very minimal. So I don't know why, like, I guess it's like a computer application. I'm using minimal RAM and lots of disk. Like, what's 2.4329 times 10 to the 18th? That's like gotta be at least petabytes. And we have two terms and then the flip digit. So I think crypto's safe, which makes me happy because I was telling people, like, get ready, you're gonna need firewalls. I'm breaking it down. And just for the very important people that I've tweeted at: Elon Musk, Steve Woz, Bill Gates, Jeff B., Richard Stallman. Sorry for tweeting at you. I'm an anxious shit. But it looks like I'm not gonna break crypto, which is wonderful. Because I don't think, unless someone figures out how to, like, improve upon that, which it might be possible, to reuse time takes a universe full of space. But maybe it's not so impractical. It's just impractical right now. I don't anticipate that being something anyone wants to pay for or maintain. It's not gonna be very. It's probably as expensive as a quantum machine, though. If we're being truthfully honest, if you apply optimization to it and reuse, if someone figures out how to reuse, then you could probably get it down to at least as expensive as a quantum machine, but you'd need very smart engineers on this problem. But I'm telling you that you can exist it. So determinism definitely is non-determinism as far as Turing machines are concerned. Um, I'm telling you this like I believe it with all my heart. Do I believe that it's practical? I don't think anything that I do is practical. That's not really what I'm aiming for. I'm not aiming for practicality. I'm just aiming for theory. And yes, I can get you the maths. I'll eventually get you the maths. The time maths are pretty good. I know that it's in poly time, so I'm not really concerned. Like I said, these aren't really space maths because I'm not writing to the tape. So we're just have a massive transition table, but that's fine due to theorem 3.16 in Introduction to Theory of Computation because they have an infinite number of configurations to have an NTM to solve 3-SAT for an unbounded input. So I too can use infinite states based on theorem 3.16 if I have to collapse it to one tape. If I don't have to collapse it to one tape, I think I could